Next, let's go to page 809 and look at example 3, where we're supposed to sketch the graph of some ellipse. Nowadays, we can always type the ellipse into the calculator, but being that it's an ellipse, it's very easy to graph, and there's most of the time no need to do so. If all we need to know is roughly what the ellipse look like, okay? So let's look at example 3. We're supposed to graph this thing and then identify the center, vertices, etc. Okay, so let's do that. So I have the equation of the ellipse copied down here. So then what happens is that the thing under x squared is the x width, okay? So as you can see, this thing is, the ellipse is longer than it is wide, so it's a vertical one. So let's draw it like this. We have, and so the ellipse is, this is a squared. Here's the formula, x squared over a squared and y squared over b squared. So what's under a squared is just minus 3 and 3. And then the other way is longer, okay? We have, it goes up to, this is 25, so what's under y is 5 and minus 5. So then, here's our ellipse. So let's just draw this thing. And it doesn't take much to draw or envision it. It's not as cute as the decimals can draw it, but it's passable for now. And then the next thing we need to know is what is c. Now, so c is equal to, from this formula, we can also write c as c squared equals to a squared minus b squared. In this case, however, we have to flip it around because b is bigger. Okay, just whichever one's bigger. So in this case, we'll call it b squared minus a squared, which is 25 minus 9, and that is 16. So c, that means c equal to 4. So the focal point is then at 4 and negative 4. And that's all the information that is required from this example. Now, if you look at the following page, you can see that they have drawn a similar thing, but looks much better, being that they use the calculator computer to do it, whereas I'm just doing this by hand. But the basic idea is there. Okay, you just envision some kind of a oval-shaped object that goes from the left side and right side responds to the square root of this number. And then up and top and bottom, the y-coordinate responds to the square root of that number. And then the c is calculated in there, some kind of difference. So that's example 3. So if the ellipse is vertical, then c will be b squared minus a squared. In general, c, that is c squared, is the bigger one subtracted by the smaller one of the vertices. And so next, let's look at example 4. So next, let's look at example 4 on page 810. We have the problem, the ellipse is called 4x squared plus 25y squared equal to 100, which is fine, but this doesn't look like that, okay? We need the ellipse to be divided by various numbers, and it has to equal to 1. What if it equals to 100? Well, the trick is then we're going to divide 100 across the board, okay? So everything will be divided by 100, and then we'll look at the ellipse that way. So we'll divide everything by 100 and force it into looking that way. So if you divide by 100, that cancels out to be 25, and this cancels out to be 4, okay? And that's 1. So we'll ignore that. So now we have an identical form as that. That is, now our ellipse is x squared over 25, y squared over 4, and equals to 1. So that gives us immediately the square root of this number will be a, because the ellipse formula is x squared over a squared. So a will be equal to the square root of 25, which is 5. And then b is going to be equal to the square root of 4. See, b is under y. So b is square root of 4, which is 2. b squared is. And then, okay, so then that gives us c, which is, do they want c? Yeah, I guess they do. And so they want C. C is the 5 squared minus 2 squared. Okay, C is whichever one's bigger, subtract by the other one of the A's and B's. So 5 squared minus 2 squared is 25 minus 4 is 21. And take the square root because that is yeah. Anyway, so that's C. So if we draw this ellipse, then it will look something like this. This is a one ellipse that sits normally on the side, and then it goes from -5 to 5, okay, from -2 to 2, and the focus points are at plus or minus square root of 21, sorry, and the negative square root of 21, and that should do it. And if you turn to the next page, as you can see, the book has drawn an ellipse that's more or less similar to what I have. And that is good enough for now. And next thing, continuing, let's look at example 5. So next, let's look at example 5 on page 811, which says that we have an ellipse that's done this way. When it's done this way, when x is plus something, that is, instead of just x, as this shows, within the square, okay, that we have stuffed something within there. And it's the same thing happening to y. That means that our new point is at a new location. This is the same, x plus 2 is the same as x minus -2. And what that means is that what is being minus 2 is exactly the location we're looking for. That is, we're going to locate the point which is -2 and +5. Something like this. We have, okay, I'll draw it like that, I guess. -2, okay, and +5. That will be the center of the ellipse. This is always true, okay, not just ellipses, but any formula, parabolas, hyperbolas, triangles, anything you can draw. When you have the new position is going to be, compared to the old position, is going to be at -2, and whatever x is being subtracted by is where the new position is. The center used to be at the origin. Okay, this one is at the origin. Now the center of our ellipse is going to be at -2 and +5, whatever it is subtracting. All right, so knowing that, then we're going to graph this thing. And not everything else stays the same, however. For example, a is going to equal to 4. Okay, sorry, a equals to 2 is the square root of 4. So that makes a equal to 2. A equals to 2, and then b is equal to 3 because that's the square root of this thing, which means this thing is a vertical ellipse again. And so we go. So b is 3, that means its height is 3 units. So it goes up to 8 and goes down to 3, okay? 8 and 3 on the y-axis. And then on the width, it's 2 units wide each side. This is -2, so the ellipse goes as wide here and as wide here. So that is how we're going to draw this thing. Let's see, what am I doing? Oh, I am going down too much. It only go down to here. So our ellipse will look something like this, somewhat round object. That looks kind of bad, but you get the idea. And then we also calculate what is C. C is equal to the bigger one, and that's 9, okay, squared, -4, and then take the square root. So C is square root of 5, which is, well, somewhere in there, okay? We draw the vertical line here. C is somewhere in here. That is just the length of C, though. So the actual position of C, so the length here is square root of 5. So the position of this thing, that is the coordinate of this point, will be equal to, this point is 5, so it will be equal to -2 is the x coordinate, okay? And then 5 plus square root of 5. That should be the exact location of the focus. And then the focus down here will be also -2. The x coordinate is the same, but the y coordinate will be 5 minus that much. 5 minus square root of 5. And those two should be the focal point. So having said that, let's look at the next page and see if the book has the same thing, and it does. Okay? And so that is how we do this type of thing. The top one is a plus, and the bottom one is a minus. And then the center is, did I say where the center is? Oh yeah, I should mention where these points are. I guess the center is at -2, +5, okay? And then so this point will be -4, +5, whereas that point will be 0, +5. That sort of thing. And all the other points are like this point will be -2, +3, and up here is -2, +8. So well, as always, please do this yourself as well, okay? That way you can solidify your understanding of this, and you will be able to do the homework, because in the homework you will do the exact same thing, this type of thing. All right, so next, let's look at example 6. Next, let's look at example 6 on page 812. Now, if you look at, I have a copy down here, we have this ellipse, and it looks like a big long thing, okay? But it is actually no different than the ellipse we saw in the previous example, like example 5. The only difference is they multiplied everything by the common denominator so that there's no fraction left, and plus all the square stuff, okay, they're like x squared plus 2 squared, all got multiplied out. So you got all the stuff that's end up with this much stuff. And so how do we draw this? A simple way would be just type this into your calculator and it'll pop right out. However, there is a way if you didn't have a calculator, and in fact we do need to know how to do this skill, is how to reduce this thing, turn this thing to look like example 5. That is to make it look like this. Okay, and then once we make it look like that, then we can figure out the ABCs very quickly. So how are we gonna do that then? Is that it? I guess this is the ellipse, I suppose. Okay. So the way we're gonna do this is something called let's see. Yeah, we are going to do it called. We're gonna do the completing the square business. Okay. The completing the square is something that you've learned in the past. If you don't remember how it's done, that's fine. We will figure that out right this moment. Okay, so to complete the square in the ellipse, we first round up the x's and put them together, and then round up the y's and put them together, like this. I'm now looking at page 813 on the following page. Okay, and we're going to round up the x's. So what x's are there? There is 4x squared, okay, minus 40x, and so we'll round it up. I guess we'll do this kind of thing. Fine. We will take 4 out of the x's, so that would leave us x squared minus 10x. I factored out the 4, just from the x's, okay? And then we'll do a similar thing to y. Here's y squared. I'll factor out the 9 so that there's only y squared left, and this thing plus 36 divided by 9, that would be 4 y. And then the 100 is still there, so we'll leave it for now. All right, and then the next step we're gonna do is this thing right here. Okay, to complete the square, we're gonna take this number, which is minus 10, we'll divide it by half and square it. So that gives us x squared minus 10x. 10 divided by half squared is 5 times squared, 25. So this becomes 25. This is completing the square. This is it. Okay? So if you don't remember doing this before, memorize this trick right now. So divide this number by half and then square it and add it here. So why is it called completing the square? This thing is now a perfect square in the sense that this thing equals to x minus 5 squared. If you don't believe me, just multiply this out. It'll be exactly that. Okay, and so that will be our next step. And so similarly, this thing will also do completing the square by dividing this number by half and then square it. That becomes y squared plus 4y and then plus 4 divided by 2 is 2. 2 squared is 4 again. So we have that 4 thing there. And so in the meantime, I'll move the 100 to the other side of the equation. That make it minus, okay? And so this equation is basically, that becomes y plus 2 squared. See, that's why it's called completing a square. We added 4 here, it turned it into y plus 2, and then we added the 25 here, and that turned this into a perfect square. And the 4 is still there, okay? So, and the 9 is still here, and we're still doing the plus. Well, all that is very good, but the question is, did we just add 25 and then add 4 for no reason? And no, we are going to do the same thing on this side also. See, this side we added 25, that is also being multiplied by 4. So that's 4 times 25, that's for a total of adding 100, okay? And that's just this part. So 25 plus 4 is being added here, so we'll add the same thing over here. And this side, we add 4 times 9. That is 36. So we'll do the same thing here to be fair. Okay, we must be fair in math. There is no getting away with being unreasonable. So this number then end up being 36. All right, so far so good. So now we have this situation right here, okay? And the next step we're gonna do, we need this number to be 1, okay? Yeah. So for this number to be 1, as we did before, the reason we need it to be 1 is our standard form for ellipse has a 1 at the end. So if it's 36, then we're just going to divide 36 across the board like we did in a previous example. Divide 36, okay? Divide 36. So then our final result, then it becomes x minus 5 squared, and then over 9, okay? That cancels out to be 9, plus over here, that is a y plus 2 squared, and divided by 4. And that equals to this thing dividing, it becomes 1. So we are good. So now we have something that looks very much like the example before, okay? Where we had here's the example before, example 5. See, where we have stuff that's dividing by numbers, and then stuff equals to 1, but it has some things that's being added and subtracted here. So the new center of the ellipse then is at positive 5. The center is located at positive 5 and negative 2. And so let's graph it. Positive 5, negative 2 would be x is positive 5, y is negative 2 down here a little bit, okay? And something like this. This is the new center of the ellipse. Because remember, this has to be minus. So if it's a plus, it's y minus negative 2. So the center is located at positive 5 and negative 2. Okay. Then the next thing is a is equal to the square root of this thing, okay? Being that this is a squared, so a equals to 3 and b equals to 2. And then c will be equal to 3 squared minus 2 squared. And then take the square root. 2 squared and take the square root. That is equal to square root of 5. All right, so we're going to draw the ellipse now. A is 3, so this is 5. Okay, so this is one vertex, okay, going back this way. And B is 2, so this is the other vertex, and this direction is symmetrical. So the ellipse goes something like this. And yeah, it has the height is 2, okay, so that this point is 5 comma 0, and down here is 5 comma let's see, that'll be minus 4, right, to be symmetrical. And this point is 1 comma minus 2, and this point is 5 plus 4 is 9 comma minus 2. And when I say this point, I was referring to this thing right here. And, well, something like that. And then the focal points are 5 minus the square root of 5. And then the other one is 5 plus square root of 5, and so on. So let's see where's the answer to this thing. Yeah, see, there is the graph in the book. As you can see, we have everything like I said that. So 5 minus, what did I say? 3. So it goes back 3. Goes back 3. Did I say 1 here? It should be, and A is 3. So 5 minus 3 is 2. This should be 2, because A is only 3. Why do I act like A is 4? So this should be 2, and this is only 8. All right. Anyway, yeah, I'm not sure why I did that, but it happens. The point is, this is the width of the distance from the ellipse to the A distance, which is from the center to one vertex, is only 3. So 5 minus 3, this makes it 2, and that's 8. The other way I got it right. See, this is yeah, whatever. But anyway, here's the answer. So please do this yourself too. Make sure you know how to do this kind of thing. Okay, and then we'll look at the next example. All right. So the next example says, which is on page 814, the following page. It says that. So example 7 on page 814 says that you have a whispering chamber. If you ever been to one of these things, they are like an elliptical room built that way. Okay, the wall of the thing is built specifically for the purpose such that if you stand at one of the focal points and start whispering, and have your friends stand at the other focal point, then you can hear each other, even though you are like in a big room with other people around and all that stuff. But if you stand at the right spot, then you can talk to each other like magic. So that is why it's called the whispering room. Well, in any case, what are we doing here? So the whispering room has a dimension, right? And then they want us to come up with the equation for the ellipse and also calculate what the focal point is. Okay, that should be able to do that. We'll do it right up here. Okay, so this is example 7 on page something. What page is that? 814. So we're giving the dimensions of the room as 46 feet wide, 96 feet long. All right. So our ellipse is draw that thing. This is 46 total, and the long side is 96. That means we'll let A equals half of 96. That's something 48. Okay, and then B, we'll let it be B equals to half of 46. That's 23. So then and then C will be equal to A squared minus B squared and square root, which is B squared. Take the big one, subtract the small one, and squared, and take the square root. That's C. So to calculate that, let's pull out some calculator and do that. My calculator is stuck down here. Okay, I got it. And yeah, let's do this. Let's calculate what C is. C is what's that? Never mind. Why? How did that come on? Get rid of it. All right, that's good. So we'll take the square root of A squared, 48 squared, minus 23 squared. And that's about it. Okay, calculate C. Give me the decimal answer is 42 point something. All right, let's just say 42. Let's not be too picky here. So C, let's say C is equal to 42. And with that information, then we have everything. So we're trying to calculate the equation of this this thing. The equation will be x squared over a squared, where a is 48 squared, and then plus y squared over b squared. B is 23 squared, and that equals to 1, with the focal point being 42. So then this whole thing is 48 Okay, so the focal point will be from the midsection, will be about 6. So this is 42. Say 42. The whole thing is 48. So you go about 6 feet from the far edge of the ellipse will be a focal point where you can stand and whisper. So that should be the answer to this problem. Okay? The ellipses are much less painful than the previous chapter that we endured, right? And C, what did it say C is? Well, it hasn't said C yet. So the equation of the ellipse, as you can see, is A is 48 and B is 23. The book squared it. I don't know that the squaring is really that necessary, but you can, of course, square it with a calculator easily enough. And C is roughly 42, like we says. So now we have come to the end of a much more pleasant section than we had to endure in the last chapter. Okay, life is always better when it's going up. And then so let's do homework. For homework, let me find it. Found it. The homework on page 815, please do problems 9, 15, 19, 23, 27, 31, 35, 37, 41, 45, 49, 55, 57, 61, and 65. Now that sounds like a lot of homework, but they're not near as tedious as the stuff in the previous chapter, where one homework problem was worth probably 5 or more or something. So please do your homework, and when you're done, I will talk about some of them. So now that you're done with the homework, let's consider problem 19. We have this particular equation. This is very similar to example 6 or something, where we have to complete the square to make this thing to look like the standard form, and then we can draw it. But just by looking at it, you notice there's an x squared and a y squared, both plus, okay, of different numbers, and then and then some x's and y's and numbers there. And just by looking at this format, you know this is an ellipse, okay, and that is how you recognize these things. So as a well, I guess let's do the completing the square and hope for the best. Let's see. To do completing the square, we do it exactly like we did in the example. We take the x's, we factor out the number in front of x squared. So that gives us 4. Let me get a better marker. So we factor out the 4 in front of x, the x's. So we have then x squared minus 4. No, it is not minus 4, it's minus 2 because there's an 8 here. So factoring out the 4, we only have 2 left. 2x, so that's that. And then plus 9 times y squared. Factoring out this thing, be minus 8, okay, y. And then we'll write the 102 on the other side, becomes minus 102. And so the next thing we're going to do completing the squares, which means we take this number, the number in front of x, and divide it by half and square it. So that would be to make it a perfect square. So that becomes 4 times x squared minus 2x. Half of 2 is 1. Squared is still 1, so that is the perfect square. And then so the next thing is similarly, this becomes y squared squared minus 8y, and divide that by half is 4, square it, and that's 16, and that equals minus 112. So we have, at this point, we added 1 times 4 is 4, so let's add it on this side as well to be fair. And then this one, we added 16 times 9, so we add that too. What's 16 times 9? I don't know. We'll just write it this way. 16 times 9. We'll deal with that later. Okay, so this becomes 4 times the perfect square is x minus 1, okay, squared. And this thing here is y minus 4. Y minus 4 squared. Okay, and you know they are squared because if you multiply this thing out, it will be exactly that. And so that will be equal to, on this side is, I'll use my calculator to crank it out. What is that anyway? So let's do the calculator where we have let's see, what is it? Negative 102 plus 4, and then plus 16 times 9. That gives us 36. Okay, that is perfect. So this gives us equal to 36. So the next goal is that we're going to reduce the 36 to become 1 by, so that we look like in the standard form of the ellipse. So divide every single thing by 36. And so dividing by 36, divide by 36, and we'll cancel this out to be 9. So this becomes 9. And this just becomes 4. Okay, and that becomes 1. So here's our standard formula. So then our ellipse is equal to x minus 1 squared over 9, okay? And then y minus 4 squared over 4, and equals to 1. So which means a is going to be equal to 3, okay, the square root of 9, and b is equal to 2, the square root of 4, and yeah, and then c is equal to 3 squared minus 2 squared, the big one squared minus the small one squared, and take the square root, which is square root of 5, and the center of the ellipse is at 1 and 4. Okay, whatever is subtracting 1 here and subtracting 4, and that would be the entire information of our ellipse. Let's see, what are we supposed to do here? I think write the equation and identify the endpoints and stuff. So we did. Okay, this is the equation, and then the distances are located. What are the endpoints? They are I suppose I should write that down. Being that this is the center, the endpoints will be let's see, the x position will be that is, our ellipse is some like this. Okay, so the center is at 1, 4, and then so this one go 3 steps. That will be 4, 4, 4, comma 4, and then over here will be 1 minus 3 is negative 2 and 4. Those are the points across. I guess maybe I shouldn't draw the y-axis. This isn't the y-axis, okay? This, and yeah, we'll just draw the x-axis. Anyway, and then the vertical points are this x equal to 1, and up here it will be this is 4 going up, so this is 1, 6, okay? 1, 6, and this is going down by 2. This will, the bottom point will be 1, 2. And then the focus points are from 1 plus. Okay, the focus points are going from 1. This is 1, 4. And the focus point go this way will be 1 plus square root of 5, being that the focus points are square root of 5 from the center, okay, comma, it has the same y value, so it's 4. And then the other side will be the minus 1. Here's, yeah. Anyway, please figure this out yourself, okay, all the details, and I will move on to the next problem. So next, let's look at problem 49, where we have a bunch of descriptions, and we're supposed to use about the graph to determine its equation. All right, so we are giving various information, and we need to draw the equation of this thing. So the ellipse is centered at 4 and 2, which 4 comma 2, which means first we will write down x squared no squares. It's x minus 2 squared. We need to do the center first. X minus 4, okay, squared, and then and then y minus 2, because that's where the centers are, 4 and 2. So we'll do the minus 2, and the vertex is at 9 comma 2, and then there is a focus here. All right. So we have, let's draw this thing out. The center is at 4 comma 2. So let's write down 4, 2 here. And then the vertex is at, what kind of vertex is that? Whatever. Here's a 9, 2, and let me see. Yeah, is the same level, right? Same height. So they're both y coordinate is 2. It's just the vertex is over there. And then the focus is at 4 plus something 2 square root of 6 over 2. So the focus point is 2 square root of 6. The distance from the focus to the center is 2 square root of 6. And the focal point is right here, which means, okay, so with that information, we should be able to, so the A, the focal point is where it sits on the longest, the major axis. So then this distance here is 5, okay? 9 minus 4 is 5. So the whole thing is 5. And so 5 will be equal to A. And then the C, this number equal to C, okay? And so we have then B equals to A squared minus C squared, as this formula states here. B equals to the square root of A squared, which is 25, minus C squared, which is 24. And so B equals to C squared, 4 times 6 is 24. Okay, so B equals to 1, which means, all right, so that's it. So the equation will be x minus 4 squared divided by, let's see, what was it? A equals to 5. Okay, so 25 total, plus y minus 2 over b equals to 1, and that equals to 1. And that should be the answer. And got to think of it, I don't think I checked the answer for problem 19. Let me do that. Yep, it is correct. It's 25 and 1. So that is so far so good. So next. Let's do problem 55. I'll write it down here, 55. Okay, the problem 55, we're supposed to, just by staring at this thing, okay, we are supposed to figure out its equation. So let's first figure out where the center is. The center looks to me at minus 2 and positive 2. Okay, so center is minus 2 and positive 2, which means the equation goes something like this. X plus 2 and then squared, okay, and then y minus 2. Yeah, y minus 2 and squared, and that equals to 1, but we need to know what is dividing by. All the stuff down here, and the stuff down there appears to be, let's do the x width is 2, right? You see that is A distance is 2, so that should be 2 squared is 4, and then the y distance is it goes from 2 to minus 1, so it's 3, so that should be 9, and that should be the answer to this problem. Let me check. 55, x plus 2 over 4 squared over 4, y minus 2 squared over 9 equals to 1. That's it. Okay, that is that's a pretty nice ellipse, right? I mean, I wish I can draw like that, but I can't. Okay, so next, let's look at the next problem. All right, so next, let's look at problem 65, where it says we have something that is an arch. Okay, we don't know what the arch is, but it doesn't matter. We'll just have an arch that is in the shape of half an ellipse. It has a height of 12 feet. This is 12. And then a span of 40 feet. So the whole thing is 40. Okay, so half of it is 20. So we'll write down 20 here. And then find the equation for this ellipse. Okay. So then we'll assume that the center is centered at the origin right here. So we have the equation then will be equal to x squared over 20 squared plus y squared over 12 squared equals to 1. Okay, that is our equation. And because this is A and that's B. Now, no, so we can write down the equation right away. Now, use that to find the distance from the center to a point at which the height is 6 feet. So we need something like this, like where this is 6, okay? The question is, how far is it to where we can hit 6 feet? So this is x, or this is the unknown, what we're looking for. It's not exactly x. We should call it, well, whatever. Whatever x is, the value of this part is, that gives it to be 6 feet. Or maybe we should draw over here. Same thing, but then x is, this is 6 feet. Then x is positive, okay? On this side is negative. So let's do that. But it's just the distance that we want. It's the same either side. Now to do that, we have to solve this equation for when y is 6, because y, in this equation, x and y are points on here, okay? So at this point, whatever the x value is, the y coordinate will be 6. And that fits into this equation. So let's do that. So and let's plug in the number. So our unknown, x squared over 20 squared plus 6 squared over 12 squared, and that equals to 1, okay? And with that, we will get, so do everything. So then x equal to 1 minus 6 squared over 12 squared, okay? Put this thing on the other side, and then we'll multiply it 12 squared, multiply it by 20 squared, okay? And that's the multiply, put it on that side, and then multiply it by the 20, and then we'll take the square root of the whole thing, and which just means that we don't have to take square root of 20 and then take the square root. We'll just do the square root sign like this. All right, so it's just 20 times the square root of all the stuff. And at this point, then we will do. We will just use the calculator and do that. And in reality, this is equal to 6 and 2 is 12 is canceled out, becomes 1/2. So this whole thing is just 1/4. And so 1 minus that is equal to square root of 3/4, or square root of 3 over 2 times 20. And then that equals to 10 times square root of 3. Okay, and that should be equal to 17.3 or so, okay? Because I remember what square root of 3 is. Square root of 3 is 1.73, so 10 times that. That should be the answer, but you can just use the calculator to do this. This happened to be a problem that is fairly easy to do by hand. But let me check to see if I'm right first before we get too far away. 17.3. Yep, that is correct. So I lucked out that way. And that should mark the end of this section.